So now we're going to take a look at volume. Now with volume, remember volume is the amount of three-dimensional space that's occupied by the object. We looked at the mass of an object. The mass is the amount of atoms it has stuffed inside. And the volume is now going to measure the amount of three-dimensional space that it occupies. There are certain shapes that are very nice. They're called regular shapes. They're very easy to take the measurements for. Then you have irregular shapes, which are not nice solid structures that take a measurement for. For example, a regular solid would be a nice cube. And a very nice cube shaped structure is very easy to take a ruler to and measure the three-dimensional measurements from. A chewed piece of bubble gum is a horrible solid to use a ruler to try to take the dimensions of after it's been chewed. It's got an irregular shape to it. There is no pattern to it. It's just this blob. So how would you take? But it occupies space, so it does have a volume. You just want to know how to measure that volume. And then you have liquids, which are very hard to take a ruler to and take a measurement of the volume. So there's got to be a special way of doing the last two examples. But with a regular solid, it's very simple. So we're going to use a cube. In this illustration, we have a cube here. And we're going to measure, here's the cube, we're going to measure the three dimensions. So the three dimensions are length, and width, and height. And once you've got that measurement, once you've collected those three measurements, you then place it into the volume formula. And the volume formula is, well, when that thing goes away, well, in the yellow, is the length of an object times the width of the object times the height of the object. That'll give you the volume of the object. That's for a cube. So the example shows you it's 1 centimeter times 2 centimeter times 3 centimeter. Well, 1 times 2 times 3 is 6, and centimeter times centimeter times centimeter is centimeter cubed. So the answer has to be 6 centimeter cubed. The amount of space, the volume of that cube has to be 6 centimeters cubed. That's the volume. Let's try another one. I measure the length, the width, and the height. I get 7 centimeters, 2 centimeters, and 4 centimeters. You multiply them together, and you get 56 centimeters cubed. That would be the volume of this example. You just multiply the length times width times height when you're working with a cube, and then you get the volume of the cube. It's 56 centimeters cubed. Try another one. So you have 3.2 centimeters, 6.15 centimeters, 3.05 centimeters for the length, the width, and the height. Multiply them together, and you get this number. So you get 60.024 centimeters cubed. Now, if I asked you to apply the significant figure rule to this this answer, what would the answer look like in terms of significant figures? Well, you'd have to say to yourself, what was the least number of significant figures I used in my multiplication? Look at the multiplication, and I have 3 sig figs in the first number, 3 sig figs in the second number, and 3 sig figs in the third number. So my answer then would have to have 3 sig figs in it. So take your answer of 60.024, forget the unit for now, don't forget the unit, but just forget it for now. And what would be the answer with 3 sig figs? Because the answer must have the least number of sig figs in it, because you multiplied, and the least number was 3, so your answer has to have 3 sig figs in it. So take a moment, write out what the answer should be with 3 sig figs, and now include the unit. And the answer should be 60.0 centimeters cubed. Because remember, the 2 doesn't bump that 0 up. And because there's a decimal, these 2 zeros are significant. Because we need 3 significant figures. That 0 makes these 2 significant because they're to the right of the first or the last, non-zeroed number. So there you go. That's the answer. That's how you calculate the volume when you're dealing with a regular solid or a regular shape. But now what happens when you deal with a volume with an irregular shape? Well, you have to use a tool called a graduated cylinder. A graduated cylinder is how we measure liquid volume. So remember the question, the last question I asked was, how do you find volume of a liquid? You just pour it into the graduated cylinder and you take a reading. And I'm going to explain how you take a reading in a graduated cylinder in a moment. But with an irregular solid, let's just use the chewed bubble gum as an example. It won't be a chewed piece of bubble gum in class. Don't panic. But let's just, so we can all visualize this in our heads, let's just take a piece of chewed bubble gum. Now, I can't use a ruler to measure the length, the width, and the height. It's impossible to do that. So what I'm going to do is I'm going to work on a relationship that I know. I know that, and it's because of a scientist, an investigator in a sense, named Archimedes came up with this idea, that when you take an object and you place it into water, the water molecules have to move out of the way of the object. The amount of water molecules that move out of the way is equal to the amount of volume that the object actually has. So that's nice to know. So we're going to fill up a graduated cylinder with a liquid which is going to be water. I would not fill the graduated cylinder all the way up to the top. That makes no sense, because then when the water moves, it's either going to leak out of the top or it's just going to go above your readings and you won't be able to take an accurate reading. So I would fill the graduated cylinder up at least halfway. You want to make sure that the liquid will cover your sample. When the sample goes in, you want to make sure the entire sample goes under the water. So now I got my graduated cylinder and I fill it up halfway, or I fill it up to a mark that I feel comfortable it's going to submerge, the object will submerge underneath. I take a reading. So let's just say, for argument's sake, it's 50 mLs. The graduated cylinder, I fill it up to 50 mLs and I take that reading. That's my starting volume, 50 mLs. Now I take my sample and I gently place my sample in the graduated cylinder. Sometimes you take the graduated cylinder, let's pretend this is the cylinder, you turn it on its side, not all the way, you just turn it on a little angle, you take your sample and you slowly place it into the opening of the graduated cylinder, and you just watch it slowly slide down inside the graduated cylinder into the liquid, and then you turn it straight, and then you place it flat on the table. Make sure the base is sitting on the table nice and flat. That's so you don't just drop it in, like air bomb it into the cylinder, and if it splashes, it'll throw the liquid out of the cylinder, and now you lose the original volume reading. You don't want to do that. So you want to drop the material in on a cylinder that's on a slant, make it slide down. Once it goes underneath the liquid, you place it normally on its base on a table, and you let it sit there for a few seconds. Water settles. Now you notice that the water level is at 55 mLs. Knowing that the water displaced, the water moved away, has to equal the volume of the object placed into the liquid, you now have to do a little calculation. You take the new reading, 55 mLs, and you have to subtract the old reading, the reading without the sample, from it, 50 mLs. What is 55 minus 50? The answer is 5 mLs. So the volume of that piece of chewed bubble gum would be 5 milliliters. Now, when we're dealing with a solid, we take the volume measurement in centimeters cubed. But I just found out my piece of gum was 5 milliliters. Here's another nice little relationship. 1 milliliter is equal to 1 centimeter cubed. So all you have to do, because you're working with a solid, if it's a liquid, you leave it alone as ml, so you leave it alone as 5 milliliters. But if it's a solid, you say the 5 milliliters is really 5 centimeters cubed. So my chewed gum actually has a volume of 5 centimeters cubed. Remember, we found it to be 5 milliliters, the chewed gum, but a milliliter is equal to a centimeter cubed. So if I have 5 milliliters, I must have 5 centimeters cubed. And that's how you take the reading. So the example I give you here is a little bit different, not much. The numbers are different, but it works the same. Now when you take a reading, and I'll try to show you this, But when you take a reading on a graduated cylinder with it empty or with it's got a mass inside of it, doesn't matter, you always look at what's called the meniscus. Now, the meniscus over here is this bottom of this wide U-shaped or cup-shaped structure inside the graduated cylinder. When you put water in, water likes to stick to the sides. But as it gets away from the sides, it kind of falls down. That's the true reading. So you don't want to take the reading of the water hanging on the sides. You want to take the reading of the water hanging in the middle. So the bottom of this bend, do you see how it's a very, very slight U or a slight cup shape? You want to look at the very bottom. That's how you line up your eye to take the measurement reading inside the graduated cylinder. You ignore the top points of this cup. You want to look at the very base of the cup. That's the meniscus. That's how you take a reading of a liquid inside a graduated cylinder. Let's see if we can find this. So here's I think a better example of how to see or read the meniscus. Two things. You want to be eye level. You want to remain eye level because you want to have a straight on view of the number. You don't want to have an angled view because it would throw you off. And you always want to measure the bottom part of the bend, right? The cup, the cup portion. This, see here, this is the meniscus area. This is actually the cup portion. And you see how the water hangs on the top here? The bottom, the meniscus, that's what you want. You want the bottom of the cup. So you see how it comes up and goes up on this side, but the bottom's out here? That's the meniscus. That's the reading. So you want your eye to be level with that, so you go across and just take whatever that reading is on the graduated cylinder. That's the volume. Now, that could be the starting volume, that could be the final volume, but that's the volume reading inside that cylinder. That's how you read a graduated cylinder. So remember, if you're trying to figure out the volume of a liquid, you just pour it into the graduated cylinder and look at the meniscus of the liquid, and that will be your level of volume. That would be your volume level. Take the reading and you're good. If you're dealing with an irregular solid and you want to find the volume, you take the water reading first. So you put water in the graduated cylinder, find its meniscus, take the reading, then you gently place the irregular solid in the graduated cylinder, take the new level meniscus, because the water would raise and change position, and then you subtract the two readings from each other, and that'll give you the volume of the irregular solid. Could you do that with a regular solid? Sure you could. If you can fit it in a graduated cylinder, no problem. But I want you to know how to do it the other way. For regular solids, you use a ruler. With an irregular solid, you use a graduated cylinder. And with liquids, you obviously have to use a graduated cylinder. Okay.